Okay, so you can see what's going on. Okay, so guys, I assigned you some equations, and what I want you to do is to actually use a graphing tool called Desmos. Okay, it's awesome. It's free, and you don't have to buy a graphing calculator and figure out how to use it like when I grew up. Okay, so wow, amazing. So, but before we do that, I actually want to explore the change in effect and its effect of the changes when we make to m and b in y equals mx plus b. Okay, so what's the most basic line, guys? Y equals x. Y equals x, right? That's exactly 45 degrees, okay, from the point of origin, right? So now here's the thing. When we actually change the slope from 1 to 2, what happens? What do you think? It gets steeper, right? Like this, closer to the y-axis, right? So if we actually graph, so you don't see it, but you can actually click on the second space in here and graph another line, which is y equals 2x. What do you see? The black line. Okay, it's it's a little bit steeper, right? And then if you graph y equals 3x, then it's going to be even steeper than that, right? Oh, by the way, guys, in the future, you can actually use this to graph your parabola, which is x squared like this, and then you have a parabola like this. Okay, now guys, so this is actually very, very useful, by the way. Okay, so what does b do? B, put it down. Thank you. Yeah.
It tells you like which y point it starts from.
VM, I can't. I mean, thank you for virtually raising your hand. But maybe you can just speak up, because yeah. Okay. You just speak up. Yeah. Unless we're doing. I mean, I never asked you guys to raise your hands, all right? Just speak up, all right? Unless we're taking turns and you don't raise your hand, and then when we're discussing, you just speak up, right? Okay, cool, guys. And I only call your name because you raise your hand instead of speaking. So go ahead to speak, right? So okay, so let's take a look at this. So the B actually displaces the line, and positive would actually would actually move the line up. So let me show you. So y equals 3x plus 1 would actually move the line up. But what do you notice these two lines? They're parallel to each other. So we can conclude that two lines with the same slope are parallel to each other. Okay, cool. And so if we do y equals 3x minus 5, then you can see this line is displaced downwards. Okay, okay, it's a vertical displacement. Okay, guys. Now, okay, now we can also find out something interesting that I mentioned to the last class. It's not within the material that we're learning right now, but if you want to find a line that is perpendicular to your line, then what you need to do is to find a negative reciprocal. A line with negative reciprocal as a slope. So what is the negative reciprocal of the slope of this line 3? Negative 1/3. Nobody figured that out in the last class, by the way. Okay, it's not difficult though, right? Negative 1/3 x minus 5. What do you notice? 90 degrees, right? Perpendicular. Okay, so that's something interesting I want you to know. Okay, and let's see here. So so we have a line 3x minus 5. Now, I also wanted you to know that if you want a line that is going downwards instead of upwards, then you look at the slope and it should give you a negative value. Then you will have a line that's going downwards from left to right, right? Okay, so if you want to look at the slope and take a look and imagine a line, it's not that difficult, right? Okay, and if the slope is actually less than 1, so let's just say 0.5, then you get the line that is actually less steep than 45 degrees. Okay, so y equals x is actually exactly 45 degrees. So the lesser it is, closer it is to 0, the less steep it is. Okay, by the way. Okay, that's the relationship between the m and also the graph. Okay, of y equals mx plus b. Okay, now so what do we need to do today? So you are assigned a line, right? So let's just say this is our line, 0.5x minus 5. Okay, so what are you going to do is that you're going to graph this line in 5 seconds by copying my equation and pasting it here. That's really easy. And then do a screenshot like this, right? Okay, so go to a document and you put your name here, okay? So I'm going to put Aria Sue Harris second. It's not the real area here, okay? And then I'm gonna actually put down the graph because I just wait, it's not working. Okay, let me go back and screen cap it again, and then paste it. Wait a minute, it's not working. Okay, my keyboard is not working properly. Okay, something is off. Okay, and then I'm gonna copy my equation and pasting it here. Okay. Yeah, don't trust it. Desmos kind of changed some of the things in there to make it appear correctly on the computer. Okay, now so I want you to actually find 3 things: the slope, the y-intercept, and the x-intercept. They're very easy. So first of all, what is the slope of this line? 0.5. That's right. Okay, the last class said, oh, delta y over delta x, right? No need, because we know the equation already. The slope is literally whatever is in front of x. Okay, the slope, once again, let me repeat, is whatever in front of x. Okay, if it's negative 35 over 36, then the x, okay, then it would be, the slope would be negative 35 over 36. Simple as that, okay? No need to reinvent anything. It's literally right there in the equation, okay? Now, we need to find the y-intercept. Intercept is when?
The graph intersects with the y-axis.
Okay, when x is 0. Okay, yeah, which is what you said, okay? But for the purpose of the calculation, I want to say x when x is equal to 0, okay? And then I'm going to say, so how do we figure out the value of y? Y is y equals 0.5 times 0 minus 5, which is equal to negative 5. Okay, so y-intercept is negative 5. It's a number.
Oh, zero.
That's right. 0, negative 5 is a coordinate. Oh, right? Okay, because it passes through a point, not a number, a point. Right? Cool. And then x-intercept, it's when y is 0. All right, now before I actually do the x-intercept, you know how it passes through 0, negative 5, right? If you go back to the Desmos and you go to the to the y-intercept, so this is the y-axis, right? This is the line. If you click on it, what do you see? 0, negative 5. Okay, so it verifies our calculation, guys. Okay, so x-intercept is when y is 0, and guess what? This one is a little bit trickier, not that much. Okay, so 0 is y, right? Okay, on the left side equals 0.5x minus 5. Solve for x. Okay, so how do you solve for x? Add 5 on each side, which is 0 plus 5 equals 0.5x minus 5 plus 5. Okay. Oh, oops. 0.5x. Okay.
Divided 5 because they were because the
because there's 1 5 dangling on one side. So I want to isolate x on one side. So leaving the x and its coefficient. Okay? And then it would be 5 equals 0.5x. Okay? And what do you do? Both sides divide by x's coefficient, which is 0.5. 5 divided by 0.5 equals 0.5x divided by 0.5. Oh, okay. Yeah. Okay. 5 divided by 0.5 is 10. I want to put x on one side. X equal to 10. Okay. Now, if you want to verify, it's very simple. Put 10 in the equation. 10 times 0.5 is 5. 5 minus 5 is 0. And y is supposed to be 0. Perfect. Yeah. So you can just verify quickly, right? By plugging it in. Okay. So therefore, x-intercept is
0. No, 10, 0.
10, 0. That's right. And 0. So we go back to Desmos and take a look at x-intercept. What do you see? And 0. There. Okay. And save this as a PDF and submit it. That's it. Okay.
That's pretty easy.